All right, so last video lecture for this unit, and we're going to be talking about energy, productivity, and food chains and food webs. So let's go ahead and get started. Okay, so let's first start with the basics of energy in ecosystems. So first of all, energy we can think of as the currency that runs everything. Just as money is what makes our society function, energy is what makes ecosystems function. Living things don't get to use all of the energy that they take in. So we can think of that as paying taxes on our energy income. It's really important that you guys understand that the sun is the source of almost all energy on Earth's surface. The only other energy sources for Earth are nuclear energy that comes from energy stored in the crust, and there is some heat energy that is stored in the Earth. All right, so we're going to talk about different ways that we can organize our thoughts about ecosystems and demonstrate how energy flows through those ecosystems. So first we got to go back and talk about a little bit of chemistry. So we have these two laws of thermodynamics that you learned in chemistry. The first law of thermodynamics says that energy cannot be created or destroyed. It can only be transformed. And then the second law of thermodynamics is the one that says the entropy of a system is always increasing. So another way of looking at these is that the first law of thermodynamics says you can never get ahead, right? If energy is currency, you can never make more energy. You can only transform it from one form to another. You can convert your currency. And then the second law says not only can you not get ahead, you can't even break even. So as we use energy, some of it is transformed into a form that we can't use, and that form is called entropy. And you guys will remember from chemistry that entropy is the measurement of the disorder of the system. So if we look at our background image here, we start out with a tree, and it receives energy from the sun and transforms it through photosynthesis into different forms of energy, stored forms of energy. So it's using photosynthesis to store the energy from the sun as glucose. We then eat those apples. So we receive chemical energy from our food. And of course, we know that we don't manage to use all of the energy from that food, and some of it is lost to entropy. But we can use some of that food energy to do work. And in that process, you guys know when you're working hard, so you're planting an apple tree, that you're going to get sweaty and warm, and we lose some of that energy again. So these are our laws of thermodynamics, and they become important as we talk about energy flow through systems. Okay, let's talk about primary productivity. We've talked a little bit about this. Primary productivity is the rate at which solar energy is converted into organic compounds through photosynthesis over a unit of time. That's the very technical definition. So what does that really mean? That means it's the amount of plant matter that's growing in a given area in a given time. So it tends to be measured in mass per unit area per unit time. Okay, so let's talk about the difference between gross primary productivity and net primary productivity. And this comes back to those laws of thermodynamics. So we divide primary productivity into two types. Gross primary productivity, that's the total rate of photosynthesis in a given area. And then we have net primary productivity. So that's the amount of energy that actually gets stored in the primary producers after we subtract the energy lost by respiration. So we can think of this as the We're going back to our currency analogy. We can think of this as the amount of money that's left after you pay your taxes and buy your food. So trees or other plants take in energy from the sun, but they're not able to store all of that energy. They have to use some of it for their processes, for cellular respiration, for their own purposes. So net primary productivity then is calculated by subtracting respiration from gross primary productivity. All right, so back to our biomes, and we talked about productivity when we talked about biomes. So among our terrestrial biomes, tropical forest is far and away the most productive biome, followed by temperate forests. And then, of course, the two least productive biomes are tundra and alpine, and deserts. And when it comes to our aquatic biomes, swamps and marshes are the most productive aquatic biomes, followed by coral reefs and estuaries. And the least productive biome is the open ocean. Now remember, we talked about this. The open ocean is the least productive biome when you look at the way we measure productivity, which is per unit area. Even though the open ocean has a very low productivity per unit area, the open ocean is enormous. And so overall, it is the largest producer on Earth, but that's because there's so much area. So when we talk about productivity, the ocean has a low productivity, but is a big overall producer. Okay, let's talk about trophic pyramids. Let's talk about the 10% rule. Okay, so this is a trophic pyramid. Trophic pyramids begin at the bottom level, which is producers. Okay, producers are those things that take in their energy from the sun, use photosynthesis to produce their own energy. So they transform 100% of the energy they receive from the sun into energy. Now, primary consumers. All consumers are things that eat other organisms. Primary consumers eat producers. So a primary consumer is a plant eater. Only 10%, so now we're back to that second law of thermodynamics, only 10% of the energy that the producers make is actually available to be used by primary consumers. So you can see that you need a lot of producers to support consumers. As we move up into secondary consumers eat primary consumers. Now we've moved one step farther away from those producers. So at each level of the trophic pyramid, only 10% of the energy that was available at the previous level is available at this level. So 10% of 10% is 1%. So only 1% of the energy that was produced by those producers is available by the time we get to the secondary consumer level. We get to tertiary consumers. Tertiary consumers eat secondary consumers. Only 0.1% of that original energy is available at this level. So as we go up the trophic pyramid, there's less and less energy available, which means that we have fewer and fewer organisms. It's pretty rare to see an energy level past tertiary consumers. There are quaternary consumers. There are very few quaternary consumers in terrestrial biomes. They are more common in aquatic biomes. So as we go up the trophic pyramid, the amount of energy available decreases by 10% at each level. We call that the 10% rule. Decreases to 10% of the previous level at each level. The number of organisms decreases, and therefore the biomass decreases. Okay, let's talk about food chains and food webs. So a food chain shows us how energy transfers up trophic levels. So we have, whoops, sorry. Here we have an aquatic food chain. So we have our primary producers, which in the ocean is phytoplankton. We have our primary consumers, which again in the ocean tends to be your zooplankton, but can be slightly larger organisms such as shrimp. Secondary consumers eat the primary consumers. Tertiary consumers eat secondary, and quaternary eat tertiary. Because the ocean has so many primary producers, it is more common to find quaternary consumers in the ocean than in terrestrial biomes. So this food chain shows how energy is transferred up the trophic levels. And you'll notice in this food chain that the arrows are always drawn in the direction that energy flows. So we would not draw the arrows going down, we draw the arrows going up. They're showing the energy flow. So primary producers here, 100% of the energy. Primary consumers can only get 10% of that. Secondary consumers get 10% of that, which is 1%. Tertiary consumers get 10% of that, which is 0.1%. So by the time we get to quaternary consumers, we have 0.001%. So significant losses in energy. And remember, the ultimate source of that energy is the sun. Okay, let's talk about a food web. So a food chain is linear. A food web is kind of a visual map that shows how energy flows. It doesn't include, it's not a straight chain. It includes lots of different organisms at the levels. It is still very, very much simplified. It leaves out a majority of the species. But you'll notice that once again, the arrows are drawn showing which direction the energy flows. So here in our woodland ecosystem, you can see that there's arrows going in lots of different directions. There are many complicated relationships, but we're still not really going past that tertiary consumer. In fact, I'm not sure that I see a tertiary consumer in this particular thing. Okay, so back to our ocean ecosystems just one more time for an example. We have a cod here. Let's look at his food chain and food web. So here is the food web for that particular ecosystem, an Antarctic food web. So everything starts with the algae. The algae get their energy from the sun, and then they are consumed at lots of different levels. So they're consumed by penguins and squid, which are fairly large organisms. They're also consumed by krill and protists, which are very small organisms. The cod is considered both a primary and a secondary consumer because it's an omnivore. The leopard seal would be a tertiary consumer, and the killer whale is a quaternary consumer. This is a food web. This is simplified. I know it doesn't look simple, but if we were to actually draw an Antarctic food web, it would look like this. And that's way too many arrows and way too much. So you'll often see these simplified drawings, and sometimes you'll see a couple of different food webs that show you different relationships. All right, so let's recap. Terrestrial and near-surface aquatic biomes get their energy from the sun. Deep ocean biomes can get their energy from sulfur vents from hot water vents near the bottom of the ocean, but they're very unusual. Okay, productivity is a measure of the amount of solar energy converted into plant tissues. Remember, primary productivity, we have net primary productivity that is gross primary productivity minus respiration. We can divide our communities into trophic levels based on the energy available and the biomass and feeding patterns. And only 10% of the total energy available in one trophic level is passed to the next. And then we show that energy flow with food chains and food webs, always drawing the arrows in the direction of the energy flow.